The last auxiliary we're going to talk about is the starting system. To spin the heavy gas turbine rotors up to self-sustaining speed, a starter has to be able to supply plenty of power, and the starter has to be able to continue to run at maximum power output for several minutes. For that reason, large power plant gas turbines require large, heavy-duty engines to get them up to speed. There are many types of gas turbine starters, including hand cranks for small portable units. But the big gas turbines installed in power plants use either air motors, diesel engines, or electric motors. A starter generally is connected to a shaft extending from either the compressor or the turbine end of the gas turbine, or to an accessory drive gear. Some starters are connected to the gas turbine shaft through a hydraulically operated torque converter and a reduction gear, such as this unit. Other starters are connected by only one of these units, either a torque converter or a reduction gear by itself. Most gas turbine starters also have some sort of disengage or clutch mechanism to prevent damage to the motor before the gas turbine's speed exceeds the starter's maximum RPM. Smaller gas turbines often use an air motor as a starter. Air motors are light and rugged and can attain very high speeds. In some plants, compressed air for the starter is stored in a tank like this at approximately 400 psi. A regulator reduces the pressure to between 50 and 100 psi before it enters the motor. In other systems, air is stored at much higher pressures, up to 3,000 psi, in bottles such as these. Just as in the low-pressure system, regulators reduce the higher pressure air to 50 to 100 psi before it goes to the air motor. Conventional air compressors generally refill the bottles and tanks. Some low-pressure tanks, however, are recharged from bleed-off air from the gas turbine they've just started up, or from another gas turbine already in operation. The bleed-off air comes from the gas turbine compressor through these tubes. In a few cases, bleed-off air from an operating gas turbine directly supplies the air motor starting up another gas turbine. Diesel engines are used most often to start up large power plant gas turbines, which provide power for black starts. Just like your car's engine, diesels require no outside source of power. They have their own electric motor starter and a bank of batteries supplying 125 volts DC. The diesel, of course, must have a source of diesel fuel, a fuel pump, a fuel filter, and an oil cooler. The diesel's own lubricating oil must be checked periodically, just as the gas turbine's lube oil level is checked. Electric motors generally start up the biggest gas turbines. They can deliver the most power at the fastest rate of any of the starters we've discussed, and they require the least maintenance. Electric starters are generally limited to starting gas turbines that are used for peak loads only, since they're useless by themselves for black starts because there would be no electric power available. A few power plants, however, have installed systems designed to use electric motor starters for black starts. These motors get their electricity from emergency generators driven by conventional diesel engines or by smaller gas turbines started up by air motors or diesels. Electric starters have protective systems to prevent overloading during startup. Turning the switch for an electric motor start activates a circuit that cuts off current to the starter when the gas turbine reaches self-sustaining speed. This simple schematic illustrates what happens. This is the starting switch. The M coil, the contacts activated by the M coil, a trip coil and its contacts, the motor, and the motor overloads and their contacts. The overloads protect the motor from current in excess of the normal full load. If excess current flows for too long a time, the overloads open the contacts in the starting circuit, cutting off electric power to the motor to prevent dangerous overheating. To energize the electric motor, the switch is turned to the start position, which activates the M coil, closing the contacts that energize the motor. When the gas turbine has reached self-sustaining speed, the starter motor automatically disengages. The gas turbine's higher speed makes the starter separate from the turbine shaft in much the same way an automobile starter disengages from the engine. When the motor disengages, a trip coil breaks the circuit to the M coil, which opens the contacts to the motor, and the starter motor shuts off. The disengagement of the starter completes the starting sequence, and the gas turbine accelerates up to operating speed.